Hello, my name is Pam Martin. I am a graduate of Bastrop High School and I now work at ULM in the math department. I've been asked to do the problem of the week this week, and so let's go to our problem. The student parking lot has 81 cars in it, all Acuras, Beetles, and Camrys. There are half as many Acuras as Beetles, and the number of Camrys is 80% of the number of Acuras and Beetles together. How many of each kind of car is in the parking lot?
Let's begin by taking each statement separately. The student parking lot has 81 cars in it, all Acuras, Beetles, and Camrys. To keep this from being confusing, we will use the letters A, B, and C to represent the number of Acuras, Beetles, and Camrys respectively. So by this statement, what we know is that the number of Acuras plus the number of Beetles plus the number of Camrys is equal 81. Let's take our next statement. There are half as many Acuras as Beetles, meaning the number of Acuras is half the number of Beetles. Acuras is half the number of Beetles. We can also take this statement and say that twice the number of Acuras is equal to the number of Beetles. This is just another way of saying there are twice as many Beetles as Acuras. Our third statement, the number of Camrys is 80% of the number of Acuras and Beetles together. So the number of Camrys, C, will equal 80% of the Acuras and Beetles together, the sum of the Acuras and the Beetles. We now have created three equations. How many of each kind of car is now in the parking lot? Let's look at the three equations that we came up with. This is referred to as a system of equations. We have three equations with three unknown variables. We will begin by looking and seeing there are some substitutions that can be made. The first one that just jumps off the page is the A plus B. Simply because I can solve for this sum, taking the 80% and dividing both sides by 80%, 1 divided by 80% is 1.2. So I have 1.2 times C equal A plus B. The A plus B will now be substituted using 1.25C. So going back up to the first equation, we can replace A plus B with 1.25C. Now we have an equation with only one unknown, which is simply solved. Adding the left-hand side, we have 2.25C equal 81. Dividing both sides by 2.25, 81 divided by 2.25 is equal 36. So C is 36. Let's return to our system of equations. We can take our value that we have found, C equal 36, and replace each of the variables C. We now have only two unknown variables. Again, we look around. I see A plus B in two different equations. However, the middle equation, the 2A equal B, gives me another substitution. We can replace B with 2A. So let's return to our first equation. Replacing B with 2A, we have A plus 2A plus 36 equal 81. Simplifying the left-hand side, 3A plus 36 equal 81. Subtracting 36 from each side, we have 3A equal 45. Dividing each side by 3, A equal 15. So now we have a value for A. Returning to our system of equations and putting A in for each of the values or the variables, we now have only one unknown variable. Now notice that the second equation only has to be evaluated. There's no solving involved, so this must be the easiest one. 2 times 15 is 30, so 30 equal B. And we now have a value for our third variable. Now let's recall what we have found. We have found that A was 15, B was 30, C 36. Remembering what A, B, and C represented, there are 15 Acuras, 30 Beetles, and 36 Camrys in the parking lot.